Before we continue with requesting other resources, we'll introduce AutoMapper into our solution. AutoMapper can be found on NuGet, so let's open the NuGet dialog and look for it. AutoMapper is an object-to-object mapper. Object-to-object mapping works by transforming an input object of one type into an output object of a different type. What makes AutoMapper interesting is that it provides some interesting conventions to take the dirty work out of figuring out how to map type A to type B. As long as type B follows AutoMapper's established convention, almost zero configuration is needed to map between two types. And that sounds exactly like what we're looking for. Entities and their relationship, in other words, the object graph of the entity model, are typically a lot more complex than the DTOs we're sending over the wire. What we want to add is the automapper.extensions.microsoft.dependency injection package. This package contains extensions to make AutoMapper work nicely together with ASP.NET Core's dependency injection system. It has a dependency on the AutoMapper package, so that will be automatically added as well. Let's install it. And there we go. In the program class, we make sure that AutoMapper's services are registered on the container. For that, we call into add_automapper on the services collection. That method allows us to pass through an array of assemblies. It's these assemblies that will automatically get scanned for profiles that contain mapping configurations. A profile is a neat way to nicely organize our mapping configuration. We could have a profile related to cities, a profile related to points of interest, and so on. So first, we state that we want to get the assemblies from the current app domain. For that, we call into getAssemblies on current domain on app domain. That will ensure that the current assembly, so the cityinfo.api assembly, will be scanned for profiles. And then we can add a profile. Let's start by adding a new folder to our project. And let's name it Profiles. Let's add a new class to it. And we name the class City Profile. Profiles should derive from the automapper.profile class. Let's import the AutoMapper namespace for that. And to add a mapping configuration, we can use the constructor. What we want to do is create a map from the city entity to the city without points of interest DTO. That's the first one we looked into in the previous demo. To do that, we call into createMap, and on that we can provide a tSource and tDestination type. The source type, in our case, is the city entity, and the destination type, in our case, is the city without points of interest DTO. As mentioned, AutoMapper is convention-based. It will map property names on the source object to the same property names on the destination object. And by default, it will ignore null reference exceptions from source to target. In other words, if the property doesn't exist, it will be ignored. From time to time, we might have to provide our own property mappings, but for a lot of objects, this is sufficient. So, now we've told AutoMapper to create a mapping from the city entity to the city without points of interest DTO. Then let's use AutoMapper in our controller. So we open the cities controller and we want to inject something new here. We need an IMapper implementing instance. This is the contract AutoMapper's mappers must adhere to. Via such a mapper, we can map a source object to a destination object, and it will use the profile we just created for that. So let's import the AutoMapper namespace, and let's name our parameter mapper. We add it as a private read-only field, and as usual, we also add a null check. So far for that. In the getCities action, we are currently manually mapping the city entities to a list of city without points of interest DTO. We no longer need any of that. To effectively map, we call mapper.map. We pass in the type we want to map to. In our case, that's an IEnumerable of city without points of interest DTO. What we pass through as source parameter are the city entities we fetched from our repository. And that should be it. As we created the mapping from the entity to the DTO, it will use that mapping to map each item in the source list to an item in the destination list. And that destination list, that is what we return. If we hover over our map statement, we also see that it will result in an IEnumerable of city without points of interest DTO. Alright, let's give that a try. We've still got that request to get the cities lined up here. So let's send it again. And there we go. Still works, but this time we didn't have to write the mapping code ourselves. Let's continue with the other GET requests in the next demo.